Hi, welcome to Professional Certifications channel. Let's break down CISSP exam preparation, one topic a day for focused and effective learning. Today's topic is Certificate Authority CA.
Definition. A certificate authority, CA, is a trusted entity in public key infrastructure, PKI, that issues, manages, and revokes digital certificates. The primary role of a CA is to validate the identity of entities, individuals, organizations, or devices, requesting a certificate and to digitally sign their public keys, thereby creating a digital certificate. CAs are fundamental to establishing trust in online and secure communications.
Key concepts.
1. Role of the Certificate Authority, CA. Issuing digital certificates. The CA verifies the identity of entities requesting certificates and then issues a digital certificate that binds the entity's identity to a public key. The CA's digital signature on the certificate assures others that the public key belongs to the named entity. Managing certificates. In addition to issuing certificates, CAs manage the entire lifecycle of certificates, including their renewal, revocation, and expiration. Maintaining trust. CAs play a critical role in maintaining trust within the PKI ecosystem. Their signature on a digital certificate indicates that the CA vouches for the certificate holder's identity.
2. How a certificate authority works. Certificate signing requests CSR. The entity requesting a certificate generates a public-private key pair and submits a CSR to the CA. The CSR contains the public key and information about the entity. Verification process. The CA verifies the identity of the requester using a process that depends on the type of certificate being issued, e.g., domain validation, DV, organization validation, OV, extended validation, EV. Issuing the certificate. Once the entity's identity is verified, the CA signs the certificate with its private key. This digital signature links the CA to the certificate and proves the validity of the public key. Distributing the certificate. The signed certificate is provided to the entity, which then distributes it for secure communications, e.g., HTTPS, VPN authentication. The public key can be used by others to encrypt data or verify digital signatures.
3. Types of certificate authorities. Root CA. The topmost CA in a PKI hierarchy. It is self-signed and trusted by all participants in the system, e.g., web browsers, operating systems. The root CA issues certificates to intermediate CAs, creating a chain of trust. Intermediate CA sits between the root CA and the end users. The intermediate CA issues certificates to end entities, such as websites or users, on behalf of the root CA. Using intermediate CAs reduces the risk to the root CA because if an intermediate CA is compromised, the root CA remains secure. Issuing CA. The actual entity responsible for issuing end-user certificates. In many cases, the intermediate CA functions as the issuing CA.
4. Types of certificates issued by CAs. Domain validation DV certificates. The CA verifies that the requester has control over the domain associated with the certificate. These certificates are commonly used for securing websites, HTTPS. Organization validation OV certificates. The CA verifies both domain ownership and organizational information, e.g., name, address, to ensure that the certificate is associated with a legitimate business or organization. Extended validation EV certificates, the highest level of validation, requiring a thorough vetting process to confirm the legal, physical, and operational existence of the organization. EV certificates trigger trust indicators in web browsers, such as a green address bar. Code signing certificates, used by software developers to digitally sign their code. The CA verifies the developer's identity, ensuring that the signed software originates from the stated developer and has not been altered. MIME certificates. These certificates are used to sign and encrypt email communications, ensuring the integrity and confidentiality of email messages.
5. Certificate chain of trust. The chain of trust starts with a root CA, which is self-signed and trusted by browsers, operating systems, and other devices. The root CA issues certificates to intermediate CAs, and these CAs issue certificates to end entities, e.g., websites or users. When a digital certificate is presented, such as during an HTTPS connection, the recipient, e.g., a web browser, checks the entire certificate chain, starting with the end entity certificate, through any intermediate CAs, up to the trusted root CA.
6. Certificate revocation. Certificate revocation lists CRL if a digital certificate is compromised or the associated private key is exposed, the CA must revoke the certificate. The CRL is a list maintained by the CA that includes all revoked certificates. Users can check the CRL to ensure that a certificate is still valid. Online Certificate Status Protocol, OCSP. OCSP is a real-time mechanism for checking the status of a certificate. Instead of downloading the entire CRL, clients query the OCSP server to determine whether a certificate is still valid or has been revoked.
7. Security of the certificate authority. The CA's private key is the most critical asset. If a CA's private key is compromised, the attacker could issue fraudulent certificates, undermining trust in the entire PKI. To protect the CA's private key, root CAs are typically kept offline in highly secure environments and only brought online when necessary, e.g., to sign intermediate CA certificates.
8. CAs in the real world. Commercial CAs. These CAs issue certificates for public use. Examples of well-known commercial CAs include DigiCert, Global Sign, Entrust, and Let's Encrypt. Internal CAs. Organizations may set up their own private CAs for internal use, issuing certificates to employees or internal systems. These certificates are not trusted outside the organization unless the root certificate is manually installed on external systems.
9. Trust models. Hierarchical trust model, the most common PKI structure, where a root CA issues certificates to intermediate CAs, which in turn issue certificates to end entities. This model creates a clear chain of trust. Web of trust, used in systems like PGP, pretty good privacy. This model relies on individuals or entities signing each other's keys. It is decentralized and does not rely on a single, trusted CA. Bridge CA. In some environments, a bridge CA is used to connect multiple PKI hierarchies. This allows organizations that use different CAs to trust certificates from each other's infrastructure.
10. Challenges and risks with CAs. Compromise of a CA. If a CA is compromised, attackers could issue fraudulent certificates, leading to major security breaches. In the past, some CAs have been hacked, resulting in unauthorized certificates being issued for trusted domains, e.g., DigiNotar. Fraudulent certificates. If a CA improperly verifies a certificate request, it may issue a certificate to an unauthorized entity, enabling man-in-the-middle, MITM, attacks or phishing. Trust anchor issues. Root certificates must be trusted by all entities in the PKI. If a trusted root certificate is compromised or misused, it can have wide-ranging implications, affecting all systems and users that trust the root.
Importance in the CISSP exam. Certificate authorities are central to public key infrastructure, PKI, and are a core concept in the security engineering and communications and network security domains of the CISSP exam. CISSP aspirants must understand how CAs issue, manage, and revoke digital certificates, the trust models in PKI, and how certificate chains of trust are validated. Questions may focus on how CAs enable secure communication, how certificates are revoked, and how compromised CAs can impact the security of the entire PKI system.
Real-world example. When you visit a secure website, e.g., a banking site using HTTPS, your web browser checks the digital certificate of the website. This certificate is issued by a CA, such as DigiCert or Let's Encrypt, and your browser verifies the certificate chain, starting from the website's certificate and following it up to a trusted root CA. This process ensures that the website is legitimate and that your communication is encrypted and secure.